Plastics. Today they're all around us, in our homes, at work, and increasingly in motor vehicles. Over 20 years ago, equipment was available to repair plastics, and now with the manufacturers incorporating plastics into more and more vehicles and extending their use to a wider range of parts, it must make sound economic sense to give serious consideration to repairing damaged plastic parts rather than replacing them. The Motor Insurance Repair Research Centre at Thatcham has conducted extensive research into the repair of plastic components, and this programme will demonstrate the three basic methods of repair: welding, bonding and fusing. Before any consideration can be given to a repair, the plastic must be identified. All these items are polypropylene, but it would be an impossible task to try to judge the type of plastic by the look or feel of the material. There are two groups of plastics, thermosetting and thermoplastic. This demonstration shows the effect of heat on the two materials. The thermoset on the right is starting to harden, and it will eventually crack as the temperature increases, whereas the thermoplastic on the left softens and becomes pliable. The thermoplastics are manufactured by heating granular material to a plastic state. This substance is shaped or moulded and then cooled. This is a typical production line using injection moulding equipment to manufacture Pocan bumpers. There are more than a dozen different thermoplastics commonly used in vehicle component manufacture, and generally they can all be repaired by either welding, adhesives or fusion. The thermosets are mostly cured by a chemical action during manufacture and can thereafter only be repaired with adhesives and not by methods involving heat. This production line produces about 40 bumpers an hour. A quick test for identifying to which group of plastic belongs can be made by cutting a very thin sliver off the subject component. The thermoplastic curls right back on itself, but the offcut from the thermoset stays straight. When it comes to identification, some vehicle manufacturers provide more information than others. For instance, there are those who give details of plastic parts in their body repair manuals, and some mark all plastic parts with code letters. However, when no information or coding is available, identification can be carried out in two ways, the first being the rather inefficient method of combustion testing, where a small strip of material is held in a butane flame and the flame colour is noted. In this case, the material burns with a sooting orange-yellow flame and smells of rubber. The operator uses the chart in the Thatcham Plastics Welding report to identify it as ABS. Unfortunately, there are many thermoplastics which produce a yellowish flame, so this method can cause confusion. A better method, which works on the majority of the most common plastic materials, is to use an organic solvent test. The area where the test is to be carried out should first be degreased, and if working on a painted surface, the paint should be removed. The test kit contains a set of 5 different solvents. They're applied to the unknown material in alphabetical order. Gloves and face mask should always be worn when using solvents. In this case, solvent C gives a positive result by proving to be insoluble. The chart supplied with the kit is consulted to identify the bumper as Pocan. A decision must now be taken as to the repair method. The bumper has suffered a long straight crack, which makes it particularly suitable for repair by welding. The hot air gun to be used has a built-in compressor, and the temperature can be controlled by means of a potentiometer. It's important to use a welding rod of the same material as the component, hence the importance of correct identification. The welding rods come in various profiles, and there is a speed weld nozzle available to suit each. As always when carrying out a repair process, thorough preparation of the surfaces is all important. When working on a painted bumper, it's necessary to sand off any paint in the vicinity of the area to be welded. The need for facial protection when sanding is obvious. To minimize the risk of the damage spreading, the ends of the crack are drilled out with a 2mm drill. The edges of the crack are then shaped into a V with a burring bit, which has a cutting edge on both its circumference and its face. This will allow the welding rod, which in this case is supplied in a V shape, to fit snugly into the crack. Care should be taken not to penetrate more than 2/3 of the depth of the material. The extent of the damage can now be clearly seen. In any welding operation, it is important that the two surfaces to be joined should remain in alignment, so they'll be tacked together using a tacking nozzle. The section of the temperature chart relating to this nozzle is consulted to determine the correct gun setting. The temperature can then be adjusted on the potentiometer. After allowing the gun to heat up for at least 2 minutes, the tacking operation can be carried out. The nozzle is held at an angle of about 20 degrees and is run along the crack without applying any pressure. The speed weld nozzle is fixed to the gun, and the temperature is again adjusted prior to carrying out the weld. The end of the welding rod is trimmed into a point to ensure a smooth start to the weld. The welding rod is inserted into the speed weld nozzle, and as soon as the edges show signs of melting, the weld can be carried out. When repairing plastic materials, there must always be strict observance of health and safety requirements, so the operator is working in a well-ventilated environment. Using the gun at an abnormally high temperature does nothing to assist the welding operation, and it can cause dangerous fumes. Contact should be maintained between the nozzle and the workpiece, but as with the tacking operation, no pressure should be applied via the gun. The welding rod, however, should be pushed well into the crack. The rate at which the welding rod is fed into the gun should match the distance travelled. It's also important to operate the gun at the correct angle. When the weld is finished, the gun is pulled away, leaving the welding rod attached. The excess rod is then trimmed off. After allowing the bumper to cool, the welded area can be sanded down with an 80 grit disc before being passed to the painter. The bumper has a non-textured painted finish, which will be reinstated. After normal preparation and priming have been carried out, a filler is applied. After flatting the filler, 2 further coats of primer are sprayed on and flatted. The usual cleaning procedures should be observed between each process. The colour can now be applied. Painting should always be carried out according to the paint manufacturer's instructions. Using the correct materials is of paramount importance. Cellulose and air-drying acrylic materials should never be used, as these can be chemically incompatible with plastics. The second and final coat of colour is now being sprayed on. To ensure that there's no detectable colour difference, the whole bumper above the trim moulding is being painted. Finally, 2 coats of lacquer are applied to complete the blending process. Some plastic components have a surface pattern, and it's necessary to restore this following repair. In this case, the effect can be achieved during the painting process by the use of textured paint as supplied by the vehicle manufacturer. So whichever method of refinishing is used, be it a standard paint finish or a textured paint finish, the repair site on visible plastic components should be of a sufficiently high cosmetic appearance to be undetectable. Furthermore, if the repair method is carried out correctly, the component should achieve up to 90% of its original strength. These 2 pieces of plastic, which have been welded together, were tested in a power press to demonstrate just how effective plastic welding can be. This heater box has suffered damage following a recent impact. It's an ideal candidate for repair since it's not a cosmetic item, and in this case it'll be repaired using adhesives. However, it is manufactured from polypropylene, which under normal circumstances can't be glued edge to edge in a repair situation, so a special repair method's required. Firstly, a 3mm hole is drilled each side of the damaged lug. The area over which the adhesive is to be used is abraded with 80 grit paper to provide a key and remove any oxidization. Using a solvent which won't leave a film on evaporation, the surface is thoroughly cleaned off. The adhesive to be used is a 2-pack epoxy resin. The operator draws the adhesive back and folds the sachets together before cutting them open. The adhesive can then be pushed out and mixed. This is an excellent method to use when dealing with 2-pack materials packaged in this way, as it ensures that the full amount of the adhesive and hardener are used and that they're mixed in the right proportions. The adhesive is applied all round the edges of the crack. Two squares of open weave fiberglass have already been cut to size. The area surrounding the lug is now coated with the adhesive and the fiberglass is set in position, 1 piece each side of the lug. The fiberglass mat is then covered with another layer of the adhesive. With the help of a piece of polythene film, the adhesive-saturated fiberglass is rapidly worked down into the fracture and into the pre-drilled holes. The same procedure has been carried out on the underside of the damaged area, resulting in adhesive plugs being formed in the 2 pre-drilled holes, which securely lock the fracture together. Finally, another coating of adhesive is applied, which will seal down any loose ends on the fiberglass. Again, this is tamped down with polythene film. The film is removed after curing. The component shouldn't now be moved for a further 15 minutes in order to avoid any damage to the repair. A quick, simple repair to an expensive component like this can save a lot of money. This bumper has a missing end cap and a missing mounting bracket. As on the heater box, the surfaces are abraded and wiped with solvent. In addition, the cap and the bracket are being similarly treated. A piece of masking tape attached to the front of the bumper will help to prevent the adhesive from seeping through. The same epoxy resin adhesive is being used as before. Care should be taken to align the components accurately, as any repositioning will reduce the strength of the repair. Finally, they should be securely clamped, but avoid over-tightening, as curing the adhesive whilst under stress may weaken the bond. For the metal bracket, a 2-part cyanoacrylate will be used. The hardener is added and mixed thoroughly. The operator wears protective gloves whenever handling adhesives. Application is carried out as fast as possible to avoid premature curing. The bracket is pressed into a generous bed of the adhesive, which oozes through the holes and has the effect of riveting the bracket securely. The assembly should be left overnight before refitting. To repair damage where welding would be difficult due to the shape and the size of the component, the technique of fusing is ideal. This headlamp is an excellent example. The retaining lug has broken off, but it can easily be repaired by fusing with a soldering iron. Both surfaces to be joined are abraded to remove any traces of oxidization. They're then cleaned off with a solvent. The broken piece is tacked into position on both sides. The soldering iron is pushed right into the gap to ensure that the material is properly melted throughout. The site is allowed to cool before carrying out the main repair. The same tip is used to begin with, and the melted plastic is spread around on both sides of the fracture. The tip is then changed to a broad shoe, which is more suitable for spreading the melted material. When the plastic hardens again, it produces an effective joint. Since this is a non-cosmetic item, a light dressing with production paper is all that's required to complete the repair. So there are 3 basic methods of plastic repair: welding for those components requiring strength, adhesives as an alternative to welding, and fusion for awkward or small components. Obviously, the repairer must use his own experience and judgment to decide whether the time spent on a repair makes it economical. However, when considering replacement, don't forget that a component such as this heater box is a slow-moving part and may take several weeks to procure through normal parts ordering channels, whereas a quick repair job, even if only temporary, can get the vehicle out of the workshop and back on the road, much to the customer's satisfaction. And whenever you're faced with a plastic repair job, remember the information that's available. Most of the paint manufacturers issue charts which give advice on painting plastics, and Thatcham has published a report on the identification of plastics using solvents and a report on plastic welding. Finally, there are the Thatcham methods manuals, which give details of where plastic components are to be found on most high-volume cars. Further details of all publications and video programs may be obtained from the Manager Administrative Services, the Motor Insurance Repair Research Centre, Colthrop Lane, Thatcham, Berkshire, RG13 4NP.